Okay, so today we are looking at function machines. So the topic of function machines shouldn't be anything that's particularly new to you because you would have seen it at primary school. But we are going to be looking at one new element, which is doing function machines with algebra, okay? When you don't have a number that goes in, but a letter or an expression. So our aim by the end of this lesson is to be able to answer this question here, which is a real past paper GCSE question. So first things first, a couple of keywords. So first thing is a function machine. What is a function machine? A function machine is when you have got something, you put a number in, something happens to it and another number comes out. We have also got input. Okay, input is what we're going to use for the number that goes in. Output is the word we use for the number that comes out. So our question says, what would the output be? So we're looking for the number that comes out if the input is 4. So if 4 goes in, what's going to come out? So if 4 goes in, we multiply it by 6 and we get the answer of 24. So if 4 goes in, the input is 4, the output is going to be 24. Now the second question says, what would the input be if the output is 24? Now we've already worked that out here, but if we didn't know that, how could we work it out? So this time we're starting with the output as 24 and we want to go backwards. We want to go back from the output back to the beginning to find what the input is. So if we're going backwards, we've got to work backwards. Working backwards means we do the opposite. And what's the opposite of multiplying by 6? The opposite would be dividing by 6. So 24 divided by 6 gives you 4. And that's what we would expect because we did that question when we put 4 in, we got 24. So if we're going backwards from 24, we should get back to 4. And finally, this is the bit that might be new to you. When the input is n, what is the output? Okay, so I'm going to draw the number line here. We've got n goes in, it gets multiplied by 6, and then we have got something. So we treat this just like any other one. Why are we using n? Well, n is, remember when we're using algebra, we have a letter that could be any number. So n could be any number. So if n goes in, we multiply it by 6. How would we write n times 6? Well, the proper way of writing it would be 6n. So if n goes in, what comes out is going to be 6n. Now we can use this expression and substitute any value for n in to find out what it would be. So for example, if n was 2, we'd substitute a 2 here, 6 times 2 is 12. If n was 20, we'd do 6 times 20, which is 120. If n was 99, we'd do 6 times 99, which is 594. This is a quick way it will get us straight to the answer by substituting in different values of n. Okay, let's have a look at another one. This one's going to be very similar. Just a one step, one thing happens. So this time we've got the input, the number that goes in. We subtract 5 to get the output. So the first question says, what would the output be? So we're looking for the number that comes out if the input is 4. So if 4 goes in, we we subtract 5. Okay, that's our new function. We've taken away 5. We're going to get -1. If you need to, draw yourself a little number line. When it comes to negative numbers, you've got to be really careful. Count back from 4, 3, 2, 1, 0, -1. So if the input is 4, the output would be -1. Second question, okay, what would the input be? So we're looking for the number that went in if the output is 24. So if 24 came out at the end, we've got to go backwards to find what went in. Going backwards, do the opposite. What's the opposite of taking away 5? Add in 5. 24 plus 5 is 29. Now, how can we check it? Is there a way of checking it? Yes, there is, because we can say, well, let's just double check. If we put 29 through a number machine, through our function machine, will it get us back to where we started? 29, take away 5 is 24. So we are on the right track. Now the final bit, the interesting bit, when the input is n, so n goes in, it gets multiplied by 5, subtracted by 5, what is the output? Well, n, take away 5, we would write that as n minus 5. That is going to be your final answer. Moving on to slightly trickier questions then. Okay, this we would call a two-step function machine. Why? Well, quite simply because we've got two things going on here. Okay, two things are going to happen to the number once it goes in. Just going to hide that first question for the moment so it doesn't distract us. So, if n goes in, let's look at the question and see what it actually says. So, what would the output be if the input is 4? So 4 is the number going in. So we do it in order of the number machine, okay? Always stick to this order, going left to right. So 4 goes in, we multiply it by 4, we get 16. We then subtract 5, we get 11. So the output would be 11. And it says, what would the input be if the output is 27? So we're working backwards. So if the output is 27, we've got to go backwards and work out what went in. So if we're going backwards, remember, we do the opposite. So what's the opposite? Taking away 5, add in 5. So 27 plus 5 gives us 32. Then the opposite of timesing by 4 is dividing by 4. 32 divided by 4 is 8. And remember, let's go back, let's check our answer, see if we get back the right answer. 8 times 4 is 32, take away 5 is 27. And that check-in method, the going back, seeing if you get back to where you started, is really important when it comes to exams. Okay, how many times have you finished an exam and you've heard your teacher say, go back and check your answers? What does that actually mean? It's about using little strategies like this as a way of checking, am I on the right track? So if you've got any sort of function machine question, to check if you're on the right track, put it through the other way, do you get the same answer? So finally, when the input is n, what is the output? So we've got the input is n, we're going to multiply it by 4, subtract 5, and get the output. So, first step, n times 4. How do we write that? Well, we write that as 4n. Then we're going to subtract 5. How would we write that? 4n minus 5. That's the answer. Okay, because we've got 4n multiplied by 4, then take away 5. Okay, let's look at one more example before we go back to that GCSE question. And this one's really important because we're going to be multiplying as the last thing, and there's something special we have to remember if we're multiplying as the last thing when it comes to the algebraic questions. So, I mean, you're probably used to the pattern by now. What would the output be? Okay, what comes out if the input is 5? So 5 goes in, we add 2, would be 7. We times by 3, 21. What would the input be if the output is 33? Let's get some space to go on top here. So the output is 33, the number that comes out is 33. And we want to go backwards and find the input. So going backwards, the opposite of times them by 3, divide by 3, that would give us 11. And then opposite of adding 2, take away 2, 11 take away 2 is 9. And again, checking strategies. Will it get us back to where we started? 9 plus 2 is 11, times 3 is 33. Yes, it does. We're on the right track. Now, finally, when the input is n, what is the output? So I said something special is going to happen now that we're multiplying as the last thing. So n goes in, we add 2, just doing it out here so we've got some space, times 3, and we get something. So the first bit's the same. N goes in, we add 2. How would we write that? N plus 2. Now we've got to multiply that by 3. And it's really important here, you are multiplying the whole thing by 3. If we're multiplying the whole thing by 3, it's like we put it in a bubble and we're saying all of that times 3. How do we put it in a bubble? Brackets. So we're going to have n plus 2 in the brackets, all multiplied by 3. Another way of thinking about it, why do we put the brackets in? Think about the order of operations, okay? BIDMAS, brackets comes first. If anything's in brackets, we know we have to do that first. And with this function machine, the very first thing we have to do, because we have to work from left to right, the very first thing we have to do is add 2. So by putting it in brackets, we're saying brackets comes first. We're going to do this step first, and then we're going to multiply it by 3. So your final answer is going to be 3 brackets n plus 2. You could multiply out the brackets. We don't need to. Okay, so that is everything that you might be asked on function machines. So is that now enough to answer this GCSE question? Okay, this question is worth 3 marks, 1 mark for each part. Let's see if we can get them. So a number machine is shown below. We've got the input, take away 7 times 3, and it gives us the output. Circle your answer in each of the following. When the input is 4, the output is one of these. So input is 4, 4 is going in. We take away 7 is going to be minus 3. Again, if you need to use the number line with your negatives, you've got one in your planner or draw yourself a quick little one on the sides. Then we times that by 3. Minus 3 times 3 is minus 9. Okay, because 3 times 3 is 9. A positive times a negative makes a negative. So your answer is going to be minus 9. When the output is 15, the input is one of these. Okay, so the output is 15. The number that comes out is 15. We've got to work backwards to find what went in. So working backwards, the opposite of times by 3 is dividing by 3. 15 divided by 3 is 5. The opposite of taking away 7 is adding 7. 5 plus 7 is 12. So number went in is 12. And finally, when the input is n, the output is one of these. So again, n goes in. We take away 7. So we're going to start with n, take away 7. And then we multiply the whole thing by 3. If we're multiplying the whole thing by 3, we put it in brackets. 3 brackets n minus 7. Is that one of our options? Yes, it is. And now we have got an easy 3 marks in the exam.